All right, good.
But you can start.
Great. Okay, thanks everybody for joining us. For those who have had time to, this is going to be a really good session with Nikola. If you haven't met Nikola from a Power BI perspective before, he does a lot, and I mean a lot, of blogging, certainly recently, on his website, which is Data Mozart. He's got a lot of experience in the Microsoft BI stack, both on premises and cloud-based, and he's also a Pluralsight author, Microsoft certified trainer and data analyst. So he's going to help us kind of dig under the covers of VertiPaq and introduce us to some of those features that people may or may not be aware of, which is really a lot of the kind of power and the foundations of what Power BI operates on top of. There's some social contacts there, and obviously we can provide those later as well. So from a Twitter point of view and LinkedIn, and obviously there's a link to Nikola's website there. So the kind of organizers and the co-hosts of the Power Break sessions, we have Catherine, who you may have heard earlier. She's based in Germany. She's passionate about data and about cats. She now has 3 cats, so she needs to update this slide. And we were having a joke about that earlier on. And she does a lot of kind of work in organizing all these sessions for Power BI and Power BI Days, and is organizing Power BI Days Hamburg, which is on the 15th of December. So look out for that one as well. And a lot of the logos as well, if you've ever noticed those really kind of nice artistic logos, Catherine draws a lot of those as well. And they look really cool. A little bit about me. I still need to kind of make mine look a bit more artsy, I guess, or a bit more modern. I'm a data analytics manager in Prerequisites in Ireland. I dabble in Power BI. I guess, you know, I'm not really a developer, more probably a power user, but I did manage to pass my DA 100 back in June, which I thought was really good. And we have a reasonable sized Power BI estate that I'm responsible and champion of, which is around about 150 people creating content and around 1,700 content consumers. So that's just the introduction to the session and the hosts. I will stop sharing now, and I'll hand over to Nikola, and he will get started. And I'll be monitoring the chat for anything that needs to be picked up.
Okay, I think, hi everyone, I think you can see my screen now.
Yes.
Okay, great. Then good evening or good afternoon from my side, and hope you are all doing fine. And first of all, thanks, Catherine, for having me today for this Power Break meeting. And thank you, Gavin, for being with us as a co-host. It's really a pleasure being with you folks here. So today I want to talk about Power BI internals and some best practices to keep your data model size in optimal condition. I believe it's quite important topic from many perspectives. Therefore, I really hope that you will enjoy the session and get some useful takeaways once we are done. Before I start talking about VertiPaq, I would like to ask you one simple question. Have you ever wondered what makes Power BI so fast and powerful when it comes to performance? When I say powerful, I mean that it can perform complex calculations over millions, sometimes even billions of rows, literally in a blink of an eye. So today we will discover what is under the hood of Power BI, how your data is being stored, compressed, queried, and finally brought back to your report. Once we're done, I hope that you will get a better understanding of the hard work which is happening in the background and appreciate the importance of creating an optimal data model in order to get maximum performance from our Power BI engine. Okay, because Gavin's so nice, made so nice introduction. Just few more sentences. For example, why I'm Data Mozart, because I live in Salzburg, and you probably know that Salzburg is a birthplace from Wolfgang Amadeus Mozart. That's why I took his last name as part of my nickname. Other than that, Gavin made an awesome introduction, so I will skip this for now. Let's start with prerequisites. I would say this is a 300 level talk, which means advanced level. So I will assume that you have some, not just basic, but I would say intermediate knowledge and experience with not just Power BI, but also data modeling in general. That being said, I expect from you to have at least basic understanding about relational databases, their structure in terms of how the data is being stored within the database, and to be able to distinct between rows and columns. Of course, knowledge of Power BI is also essential to follow along, because I will often refer to some things related to Power BI development that I assume you're familiar with. Let's quickly walk through agenda. So we will learn what is a VertiPaq. That's our central topic here. How it stores the data, what kind of algorithms VertiPaq applies to compress the data, and how we as users, as developers, can help VertiPaq to build an optimal data model for us. Finally, if there is not enough time, I would like to show you a short demo. This is a real-life example how I managed to reduce Power BI data model size by 90% just by sticking with few best practices, or not rules, just best practices that we will talk about today. Okay, here we are. So what is a VertiPaq? Before we answer to this question, we should mark the line between row store versus columnar databases. First of all, VertiPaq is a columnar database. As you can see in this illustration, columnar databases works and stores the data and compresses data in a whole different way compared to traditional row store databases. Columnar databases are optimized for vertical data scanning, and they are being used in large analytical systems. That means that each column is structured in its own way and is physically separated from other columns. Sorry. Another important distinction in order to understand what is VertiPaq is to understand the difference between formula engine and storage engine. In this illustration taken from the book Definitive Guide to DAX from Marco Russo and Alberto Ferrari, you can see how this architecture looks. Of course, this is in most simplified way. So formula engine accepts the request, processes it, generates the query plan, and finally executes it. On the other side, storage engine pulls the data out of tabular model to satisfy the request issued within the query generated by the formula engine. Storage engine can work in two different ways in order to retrieve requested data. First one, let me zoom it a little bit, is a VertiPaq, which we will talk about today. VertiPaq keeps the snapshot of the data in memory, so in cache memory. And this snapshot can be refreshed from time to time from the original data source. Frequency of data refresh depends on your business needs. It can go from half an hour to, I don't know, once every 6 hours, every 8 hours, once per day, once per week, once per month. It really depends on your specific business case. On the other hand, direct query, we will talk about direct query also today, but just some basic stuff. So direct query doesn't store any data. It just forwards the query straight to the data source for every single request. Formula engine represents the brain of Power BI. As I already stressed, formula engine accepts the query, and since it's able to understand DAX, it translates DAX into a specific query plan, and that query plan consists of physical operations that need to be executed in order to get the results back. Those physical operations can be joins between multiple tables, filtering conditions, or aggregations. It's important to keep in mind that formula engine works in a single-threaded way, which means that requests to storage engine are always being sent sequentially. Once the query being generated and executed by the formula engine, the storage engine then comes into the scene. Since it physically goes through the data stored within the tabular model, which is a VertiPaq, or goes directly to a different data source, like SQL Server, for example, if you are using direct query storage mode, we can think of storage engine as the muscles of Power BI. When it comes to specifying the storage engine for the table, there are three possible options to choose from. First one is an import mode, which is the most common way to store the data when working with Power BI. Import mode is based on VertiPaq. So that means that table data is being stored in memory as a snapshot, and data can be refreshed periodically. The second one is a direct query mode. When you are using direct query mode, data is being retrieved from the data source at the query time. That means, in other words, that data resides in its original source before, during, and after the query execution. Finally, the last option is a dual mode, which represents a combination of the previous two options. So data from the table is being loaded into a memory, but at the query time, it can be also retrieved directly from the source. As opposed to Formula Engine that doesn't support parallelism, Storage Engine can work asynchronously. That's also important to know. How VertiPaq stores the data. As you may recall from the previous part of our session, the main characteristic of VertiPaq is that it's a columnar in-memory database. So VertiPaq applies different types of compression to each of the columns independently, choosing the optimal compression algorithm based on the values in that specific column. Compression is being achieved by encoding these values within the column. But before we dive deeper into a detailed overview of different encoding types and techniques, just keep in mind that this architecture is not exclusively related to Power BI. In the background is a tabular model, which also works under the hood of Analysis Services Tabular and Excel Power Pivot. Let's now examine the encoding types which VertiPaq applies in order to compress the data. First one is a value encoding. This is the most desirable encoding type since it works exclusively with integers. Working with integers require less memory than, for example, when working with text values. How this looks in reality? Let's say we have a column containing a number of phone calls per day, and the value in this column goes from 4,000 to 5,000. So what the VertiPaq would do here is to find the minimum value in this range, which is in our example 4,000, and VertiPaq will set this minimum value as a starting point. Then it will calculate the difference between this value and all the other values in the column and store just this difference as a new value. You can notice in our example that using this technique, we managed to preserve 3 bits per one row, which might not look like a significant saving. But if you imagine that this table has, I don't know, 100 million rows, hundreds of millions rows, or even billions, I think that you will appreciate the amount of memory saved using value encoding. Hash encoding is probably the most used compression type by VertiPaq. Using hash encoding, VertiPaq creates a dictionary of distinct values within one column, and afterward replaces real values with index values from the dictionary. Again, taking a look at the example will help to better understand this concept. So as you can spot here, VertiPaq identified distinct values within the subjects column, built a dictionary by assigning indexes to those values, and finally stored index values as pointers to real values. I assume that you are aware that integer values require way less memory space than text, so that's the logic behind this type of data compression. Additionally, regarding hash encoding, by being able to build dictionary for any data type, VertiPaq is practically data type independent. And this brings us to another key takeaway. No matter if your column is of big integer or float or text data type, from VertiPaq perspective, it's all the same. VertiPaq will create a dictionary for each of those columns, which implies that all these columns will provide exactly the same performance, both in terms of speed and memory space allocated. Of course, by assuming that there is no big difference between dictionary sizes between those columns. So when someone says to you that data type affects column size, it's a myth. So it just affects dictionary size, not column size itself. On the other hand, number of distinct values within the column, which is known as a cardinality, mostly influence your column memory consumption. Finally, third algorithm which VertiPaq applies is run length encoding, or RLE abbreviated. RLE creates a kind of mapping table containing ranges of repeating values. Again, I will show you examples so you can better understand how this looks like. In real life, VertiPaq will not store this start column. I put it here just for the sake of clarity, but in real life, it doesn't exist. So only count column, because VertiPaq can quickly calculate where the next node begins just by summing all previous values here. As powerful as it might look at first glance, RLE algorithm is highly dependent on the ordering within the column. So if your data is stored the way you see in our example, like here I have many repeating values, then another bucket starts here and I have again many repeating values, then another one. In those situations, RLE will perform great. However, if your data buckets are smaller and rotate more frequently, then run length encoding would not be an optimal solution. One more thing to keep in mind regarding run length encoding, it always comes after hash encoding. So Vertipack will first apply hash encoding and create a dictionary of the subjects, and then it will apply run length encoding algorithm. So the final logic in its most simplified way, of course, would be something like this you can see on your screens. So basically, run length encoding occurs after hash encoding in those scenarios when Vertipack thinks that it makes sense to additionally compress the data. So when data is ordered in that way, that RLE would achieve better compression than applying hash algorithm only. Let me just briefly iterate through the process of data compression for a specific column. So first thing that Vertipack does, it's scanning of a sample of rows from the column. And if the column is in column data type in that sample is not an integer, it will look no further and it will use hash encoding. If the column is of integer data type, Vertipack will evaluate some additional parameters. If the numbers in that sample linearly increase, Vertipack will assume that it is probably a primary key and it will apply value encoding. On the other hand, when evaluating value range, if numbers in this range are reasonably close to each other, so like in our example with 4,000 to 5,000 phone calls per day, Vertipack will use value encoding. On the other hand, when values fluctuate significantly within this range, for example, between 1,000 and 1 million, then value encoding would not make sense and Vertipack will apply the hash algorithm. One more very important thing, no matter how smart Vertipack is, it can also make some bad decisions based on incorrect assumptions. So sometimes it can happen that Vertipack makes a decision about which algorithm to use based on the sample data, but then some outlier pops up and Vertipack needs to re-encode the column from scratch. This process is called re-encoding. So let's use our previous example for the number of phone calls, and just imagine that Vertipack scans the sample and chooses to apply value encoding. Then after processing 5 or 10 million rows, all of a sudden it found 500,000 value. It can be an error or whatever. Now Vertipack will reevaluate the choice and it can decide to re-encode the column using the hash algorithm instead of value encoding algorithm. And that would obviously have an impact on the whole process in terms of time needed for reprocessing. So here is the list of parameters in order of importance that Vertipack considers when choosing which algorithm to apply. First one, as already mentioned, is cardinality or number of distinct values in the column. Then data distribution within the column, which means that column with many repeating values can be better compressed than one containing frequently changing values, because as you already saw, run length encoding can be applied on top of hash encoding. Next one is number of rows in the table, and finally column data type, which, as already said, impacts only dictionary size. Once the DAX query, I want to talk about relationships because it's also important thing when thinking about data model size optimization. So once the DAX query being generated by the formula engine, storage engine enters the stage and starts its physical work in order to satisfy the request. And relationships play a big part in this process. So they enable quicker transfer of the filter context between related tables. The most important thing to keep in mind regarding relationship is the higher the cardinality of the column that makes part of the relationship, it's the higher cost of that relationship. So when cardinality of relationship exceeds 1 million, users can notice lower performance in the report. So if you identify relationships within your data model that have cardinality above this threshold, maybe you should start thinking of possible ways to optimize this. And one of the reasonable solutions could be creating pre-aggregated tables with different levels of granularity, so you avoid expensive relationships at the query time. Another important concept is materialization. Now that we know what are the roles of formula engine and storage engine within the tabular model, let's talk a little bit about materialization. So materialization is a step in the query execution process typical for columnar databases. Whenever formula engine sends the query to a storage engine will physically go through the data and return an uncompressed table that contains requested data. The keyword here is uncompressed, so uncompressed table. This special temporary storage is called data cache, and it represents the materialization of the data that will be absorbed later by formula engine. It's important to know that both VertiPaq and direct query produce these temporary data cache structures. Therefore, you should be aware that there are two types of materialization. Late materialization, which occurs in those situations when storage engine produces one single data cache with exactly the same cardinality as produced by a DAX query. On the other hand, when storage engine generates multiple data caches, or when data cache has higher cardinality than one generated by a DAX query, we are talking about early materialization. The main advantage of late materialization, and you should always tend to achieve late materialization, is that formula engine gets already prepared data, while with early materialization it needs to perform some additional stuff such as joining or aggregating, which implies that the end users can experience slower queries. The key takeaway here is, whenever possible, push most of the workload to storage engine, as that will reduce materialization, and consequentially formula engine would have to cope with less complex tasks. Finally, last concept is aggregations, and aggregations are nothing more than reorganized versions of the source table. So you can have multiple different tables related to same original table. By pre-aggregating data on different levels of granularity, we can help storage engine to work faster and scan the data in more efficient way. Applying different aggregations, we are reducing the amount of data, basically reducing the number of rows and or columns. If you take a look at my example, my row table contains 7,346 rows for chats between July 9th, 2017 and July 10th, 2017. Now, if I pre-aggregate data and count number of chats per specific subject, my aggregated table will have only 45 rows. So if my users need to analyze data per date and or chat subject, having this kind of prepared table in advance will make the storage engine's job much easier, and it can retrieve the data much faster. One important thing to keep in mind regarding aggregations, they don't have any impact on optimization of the complex DAX calculations. So they are just enabling storage engine to work more efficient and reduce the time needed to execute the queries. Aggregations work only with native columns from your data model. In other words, you can't perform aggregations on calculated columns. That's also important to keep in mind. In reality, you don't need to apply aggregations on each fact table. Aggregations make sense with VertiPaq because VertiPaq is optimized for large fact tables. It makes sense to use aggregations only for extremely large tables, for example, few hundred millions of rows or few billions of rows. Finally, be careful when creating aggregation, as each mistake can prove costly, because if not defined in proper way, aggregations will produce incorrect results in the report. Moreover, having aggregations require additional effort for data model maintenance. Just also that keep that in mind. Okay, short demo. Hope that we have enough time. And as we lay the solid theoretical background, I think we can get our hands dirty a little bit. So this demo is based on a real use case which I faced during the last year. And the problem was that the size of PBX file on our report server dramatically grown since the report was had been introduced. Just one thing before we proceed, for the demo I've created 3 separate PBX files in advance, each of them representing one single phase in the data model size optimization. So we don't need to work on one single file and wait for Power BI to apply all changes we made during the process, as in some cases it takes a while to reload the data and recreate the data model. Okay, I will show you the first one. I put simple card visual in each of those reports, so you can just see that data accuracy is not being violated by applying different development steps. So here is my data model. I have a fact chat table in the middle, and I simplified it, removed some dimension tables, and as you can see here, my fact table has around 9.3 million rows. So it's nothing special in terms of volume for Power BI and for VertiPaq. So the main problem is that all tables were imported as it is. So just check the table name and import mode without any additional optimization or transformation. To be able to follow what is going on with our data model, I will use Dex Studio. For those of you who are not aware, Dex Studio is a fantastic free tool, and it has a whole bunch of very handy and useful features. And that being said, I will connect to Dex Studio directly from Power BI Desktop. Of course, the prerequisite is to have Dex Studio installed on the same machine as your Power BI Desktop. I will be automatically connected to my data model. So here on the left-hand side, you can see all of the tables for my data model. If you are wondering what are these tables with strange names and bunch of weird characters, these are automatically created data tables by Power BI. We will come later into this in more details, just for you to know at the moment. And one of the favorite features within Dex Studio is VertiPaq Analyzer tool that help us to see the numbers behind our data model. Before I open VertiPaq Analyzer, let me just show you something. So this is the starting point, 771 megabytes. That's how big is my PBIX file. Okay, so 771 megabytes. But it's even worse because it's not just PBIX file size that's being calculated as your for your data model size. It's also dictionary. We talked about dictionary previously while explaining hash encoding. Also hierarchies, both column hierarchies and user-defined hierarchies, and relationships within your data model. Now, if I go to Advanced tab and click View Metrics, it will launch VertiPaq Analyzer. Okay, so before I proceed, let me just briefly walk you through this main metrics here. So I can see all of my tables. I can see maximum cardinality, maximum size within my table, etc., etc. All these numbers are in bytes, just for your for you to easier calculate this. Now, if we go to this small arrow next to a table name and click on it, I can see all those numbers broken down by column within specific table, and I can immediately locate the most expensive columns within my table. I can see the cardinality of the column. I can see the column size. Important to know that column size it's just a simple sum of data within column, dictionary size, and hierarchy size. So these three make this one. Okay, and I can see which encoding type VertiPaq applied for specific column. It's also useful to know. And very handy feature is to see the percentage of the memory that one column occupies within the table. Okay, so if I go to this summary tab, I can see that my data model size is 1.86 gigabytes. So that's the whole size of my data model, 1.86 gigs. So let's go back to this fact chat table and see what we can do. So for example, first and starting point will be to locate unnecessary columns and get rid of them. That being said, I have this chat ID column, which is just a surrogate key from the data warehouse, and I have source ID, which is a primary key from the source system. Other than that, I have two date time columns. One stores starting point in original time zone when chat started. Another one is the other one stores converts this time to UTC. So in any, I don't need both of those columns in any scenario. So I can get rid of date TM start, and later if I need to calculate for different time zones, I can use I can perform calculations within the report itself. So I don't need to import both of those columns. Also, some very expensive text columns like session referer. And here is one important thing to know. When you see expensive columns and you notice that they are not being used in the report, talk to your users and ask them if they need to perform any kind of analysis on them. If they don't need them, then don't keep them. You can remove them from data model. No need to bloat data model with unnecessary columns. So I will go back to Power BI desktop and I will get rid of these few unnecessary columns. And you can see the significance of getting rid of unnecessary columns. So I will get rid of date team start. That's the first one. Then a referer, session referer. You see that it's a bunch of strings completely useless without any additional transformation. Source ID, then last edit date is just an information when the record was last time updated in my source system. Chat variables, and I think that's it. Okay, so I will remove those columns, hit close and apply, and I will wait a few seconds for Power BI to apply those changes. And after that, let's go back to Text Studio. Okay, it was fast. Again, I will click on View Metrics. That will refresh the connection to my data model. And now if I look to Summary tab, I can see that now my data model size is 660 megabytes. So we shrinked 2/3 of data model size by just removing few unnecessary columns. Truth to be said, there are some more columns which could be dismissed from data model, but I now want to talk about other techniques for data model optimization. So as you may recall from the previous part of our session, when I was talking about the order of importance of parameters that affect your data model size, I mentioned that cardinality is number one. The rule of thumb is the higher the cardinality of column, so the more distinct values in the column, it's harder for VertiPaq to optimally compress the data, especially if you're not dealing with integer values. So there are multiple different techniques for reducing the column cardinality, and the most popular one is column splitting. So I'll share with you now a few examples of using this technique, and you can see how to do this in reality. So first one, when you're working with integer columns, you can use division and modulo operations to reduce the cardinality. How that looks, I will execute this query. Wrong F, okay. So instead of having one column with high cardinality, I have two columns. This one has cardinality of 1, and this one has higher cardinality, but I have only three characters in this column instead of 7. So that again brings us to the previous part of the session when I talked. You remember 3 bits per row. It's nothing. It's nothing when you look at 10 rows. But if you have, I don't know, 100 millions of rows, and yeah, this can bring significant saving. Another thing, when you're working with decimal values, you can split decimal values before and after a decimal point. So you get something like this. Instead of having a decimal column, you have 2 whole number columns with lower cardinality. Similar thing for date time columns, you can split them and have separately, you can split date and time to have them as a separate column. That will also reduce cardinality. In 95% of scenarios, you don't need to do this. But if your date time if your date time column is large and has a lot of distinct values, maybe you can try to do this, and that will help in some scenarios, definitely. Let's go back to our example, and I can see that date team start UTC has a cardinality of almost 9 million. And it occupies 67% of my effect table, so it's quite large. And there are multiple different ways to optimize this column. I talked with my users, and they were satisfied to have data granularity on hour level, so I could get rid of minutes and seconds at least. So in 95% of cases, again, I will repeat that day level granularity is completely fine, but for my specific case, hour our level granularity was what users wanted. So I rounded. I will show you how. So I used t-SQL script to round all my chats. So all chats which started between 30000 and 35959 was rounded to 3000, so to starting hour. And let's see what kind of savings that brought to me. This is the second PBIX file where I applied this rounding to hour. So going to DAX Studio from this second PBIX file, and let's go to advanced view metrics. Okay, and now if we go to summary, I can see that my data model size is now 220 megabytes. So we started with 1.86 gigs and we are now at 220 megabytes. And now if we go to my fact chat table and let's locate the ATM start UTC, instead of almost 9 million, it has now 32,000 distinct values. So it's massive saving, really. And the final thing, this column chat ID, which occupies almost 1/3 of my table, and it's not being used in any relationship. It's just a surrogate key from data warehouse. And just to be clear, don't be confused and think that all these columns with ID suffix can be removed like this chat ID. This IP address ID, customer ID, user ID, those are foreign keys to our dimension tables, and therefore they are part of the relationships in our data model. But chat ID column is just a surrogate key and is not being used in any relationships or calculations. So finally, I removed this chat ID column, and this is the final version of PBIX file. I'll go to external tools and to DAX Studio again. Okay, so going to advanced and view metrics. Now, if we go to summary, I can see that my data model size is 161 megabytes. So I started with 1.86 gigs and finished with 161 megabytes. Oh, I forgot one thing. I promised for these date tables. Okay, so that's the last step, is to disable auto date time options, auto date time in options for data load. If you're not aware, when you leave auto date time option checked, it will create a hidden date table for every single date field in your data model. And what is even worse, Power BI will scan your whole data model and find the minimum and maximum date in your whole data model. So if it happens that you have something like December 31st, 2099 for current records in your data warehouse, your date tables will span until that date, and it will bloat your data model. So just do this and create a proper date dimension. Of course, that's the topic for a separate session, but keep that in mind. So how can I do this? Go to File, Options and Settings, go to Options, and under Data Load, you see here this time intelligence, and by default it's checked, so it's enabled. Auto date time, it's enabled. Once I disable it and click OK, and let's go back to DAX Studio. Just to refresh this, it's 157. Okay, additional 4 megabytes, nothing special, but yeah, still, because my date range was not so big. Maybe some of you now think, after watching the demo, why all this talk about VertiPaq, encoding types, and cardinality? What you just shown is basically just removal of unnecessary columns. And that's true. In 95% of cases, when you're performing data model size optimization, simple removal of unnecessary and unused columns will be enough to get your job done. And that should always be your starting point when you're dealing with data model size optimization. In those remaining 5% of scenarios, you would maybe need to apply some more advanced approaches, such as cardinality reduction, using some of those techniques I've shown you a few minutes ago. Okay, so yeah, that's reducing cardinality shown in presentation, but I've shown you is in SQL Server Management Studio. So we can go directly to summary. And here is the list of best practices or general rules you should keep in mind when trying to reduce your data model size. Keep those and only those columns your users need in the report. Just sticking with this one single rule will save you an unbelievable amount of space, I assure you. As you've just seen in our demo, sticking with this one rule helped us to make some astonishing savings, really. Then try to optimize column cardinality whenever possible. There is no golden rule here, so the golden rule here is test. And if you notice a significant benefit from, for example, splitting one column into two columns or substituting decimal column with two whole number columns, of course, then do it. But also keep in mind, if you're performing this, that your measures need to be rewritten to handle those structural changes in order to display correct results. So if your table is not so big, or if you have to rewrite hundreds of measures, maybe it's not worth splitting the column. As I said, it depends on your scenario, on your specific case, and you should carefully evaluate and test which solution makes more sense. Same as for columns, keep only those rows you need. For example, maybe you don't need to import data from the last 5 years, maybe only just 2 or 3 years. That will also reduce your data model size. As I already mentioned a few times, but it's never too much. Talk to your users, ask them what they really need before, blindly put everything inside your data model. Aggregate your data whenever possible. That means fewer rows, lower cardinality, so all nice things we are trying to achieve. If you don't need hours, minutes, or seconds level of precision, don't import them. Aggregations in Power BI, as we already saw in previous part of the session, and tabular model in general, are a very important and wide topic which is out of the scope of this talk. But there are some really awesome resources on the web, and I strongly recommend reading a blog series on creative aggregations from Phil Simark on dex.tips. Avoid using calculated columns whenever possible. They are not being optimally compressed. If you need to do some calculations, try to push all calculations to a data source like SQL database, for example, or perform them using the Power Query editor. Use proper data types. For example, if your data granularity is on a day level, there is really no need to use date time data type for these columns. In those situations, plain date data type will be completely fine. And finally, disable auto date time option for data loading, as this will remove a bunch of automatically created date tables in the background. That was from my side. Looking forward to hearing your questions. Or maybe it's better to say, let's chat about this topic, and I would like to hear your experience. Did you face some similar scenarios, and what techniques did you use to optimize data model size? Okay.
Thanks a lot, Nico. That was really good. I think there's a lot of chat being going on as well. So I think from a, I think that it covers a lot of some really great techniques there on looking at ways of optimizing your data model and everything else. I think on the date time, the auto date thing, there's also a global setting as well, isn't there?
Yeah, exactly. You can set for not just for specific PBX, for specific report, for specific PBX, but also for global setting. Yeah. Okay, I'm walking through the chat just to see if there are some questions.
One of the points that you made as well, about filtering the data. I think it's really important, filtering it early, both rows and columns, because it just makes everything work so much better.
Exactly.
Particularly, to enable to keep query folding for as long as possible. I'm not really sure there's any other questions. I think there was kind of a bit of a discussion around the optimizing the integer columns, right? Kind of splitting the integer columns, because at some point your initial 4-digit value will be exceeded, right? And you end up having 5 digits. So was there a way to actually think about planning for that in the future? On the model that you were showing, I think you had like 1734 was the same number for the first so many thousand rows, obviously, then you split it out. for the second part of that column, the integer split. But at some point, 1734 will become, 11734, so it will get bigger.
It makes sense with really big tables. I would say with few hundred million of rows, or even billions of rows. For normal tables, let's say with, I don't know, 20, 30 million rows, there is no need to do this kind of how should I say, this kind of gymnastic.
Yeah, I know. Yeah. So 20, you're talking about 20 or 30 million rows, you don't need to bother. So obviously Excel isn't a data source that you're using frequently, right?
Yeah. Same as everywhere, yeah. Okay, thanks for the water. From my friend, Real Madrid supporter, yeah. Thank you. Yeah, business requirements, that's the key thing. So talk to your users before. Yeah, I made a lot of mistakes, putting different kind of things in reports, and later, yeah, my users were, what? We don't need this. Okay. That's how I learned.
Yeah, very good. And just to kind of, and if anybody hasn't seen it, obviously Catherine mentioned that we were joined by Marco sometime early next year. So, but they also put up a great video recently on specifically talking about the formula engine and the storage engine, which really helped explain it as well. And I think that just the presentation you just gave is probably more detailed than that. But I think you can certainly, if you follow that and have a look at it, that was a really good presentation as well.
Yeah, looking forward also to Marco's presentation to hear.
I think, Catherine, did we decide on a topic? I can't remember if we did or not. Catherine's on mute, but we were kind of talking about different topics that we should be including. I can't remember what we ended up on, if we did end up on one. I kind of think we did.
Sorry, just want to emphasize the great point from Tom Martins in chat. A certain point that should not be forgotten. If you keep your model concise, it can longer be kept in the pro licensing. So it's not just about performance, it's also about money. Excellent point. Thanks, Tom. Yeah, excellent point.
Good point, Tom.
Okay. Yeah, because if you go over 1 gig, you cannot handle this with pro license.
I mean, in the models that certainly we built from the business that we've been in, we don't have anybody who's close to a gig anyway, I think, but it's definitely good to remember.
Yeah. Yeah, I mean, in the beginning, everything is fine. This report was fine when we introduced it. Yeah, because it has, I don't know, 100,000 rows. But during time, your data is growing, and yeah, you need to find the right balance then to optimize this data model size.
Okay. No, Catherine's Teams crashed, so she'll restart and log back on again. So I hope we got all the recording anyway, all the good stuff. Okay. So I think, Catherine was just saying that it's just the topic is about DAX generally, I think, with Marco early next year. But yeah, I think we have Reed Havens in a couple of weeks, or early December. I think second week in December. So that'll be good as well. And Catherine's Teams has crashed, so she'll be back on in a minute. Yeah, definitely, and thanks very much, Nikola. It was a great session. I've been enjoying reading your blogs about the the query costs with signups and everything else as well has been really interesting.
Okay, yeah, that's hot topic now. Yeah.
We're not using it, but it was interesting to read about it. I mean, you know, from a business point of view, they've decided that AWS is the chosen cloud platform.
Okay, okay.
The similar issues, similar things that they have there, so it's good to understand the principles.